This is the from the chapter number 1 force 1a from that numericals. And in the 1a in the question answers I left the 27th question in multiple choice that I'll discuss in the next videos. Okay, and in this video I'm going to solve the numericals from 1 to 9. So the first problem is the moment of a force of a 20 Newton about a fixed point O is a 10 Newton meter. Calculate the distance of a point O from the line of action of the force. So in this what and all they have given. Force they have given 20 Newton. Okay, and another one is 10 Newton meter, means they are given directly moment of a force. So what we need to find out here, we need to find out distance of the point of a O from the line of the action of the force. So basically we have to find here distance. So distance is equals to question mark. Now formula, as you know, the moment of force equals to force into distance. Now substitute the values in this, and after calculation, after solving, you will get 1 by 2 either or 0.5 meter. That's it. We'll go to the next question. So what is the second one? A nut is opened by a wrench of a length 25 centimeter. If the least force required is 10 Newton, find the moment of force needed to turn the nut. So here they are given distance, that is 25 centimeter, but which is in the centimeter, that you convert to meter. Divide it by 100, you will get the meter. She forgot to write here meter. Next, if the least force is 10 Newton, it means force equals to 10 Newton. Find the moment of force. So what we need to find here, moment of force equals to question mark. As we know the formula, force into distance, and substitute these values in this formula, you will get 2.5 Newton meter as a answer. That is the moment of force. Now third one question. A wheel of a diameter is 2 meter is as shown in the figure with axle at a O. A force F equals to 2 Newton is applied at a B in the direction shown in a figure. Calculate the moment of force about the center of O and the point. So first we'll study the diagram. Okay, before that. Now, a wheel of diameter is 2 meter. Diameter is 2 meter means from here to here it is a 2 meter. Okay. Now with the axle point O, here is the point. A force F is equals to 2 Newton is applied at a point B in the direction as shown. So in which direction this is? Clockwise direction. Now shown in the figure, calculate the moment of force about the center O. One is at the center and another at the point A. Here is the point A. Another at the point A. Now, what and all they have given? Distance D1, D2, this diameter is 2 Newton meter. If you are finding the moment of force for the at a point A, that time the distance will be 2 meter. But if you are finding the distance for the B from the O, that will be 1 meter. So D1 equals to 1 meter, D2 is a 2 meter, like that. Force is a 2 Newton for both. Now formula moment of force again apply, and the D1 is distance is 1 and the force is 2 Newton. 2 into 1 you will get 2 Newton meter. Moment of force at the head. So this was the at the point of B here, at the center, to find out the B here, and this is the moment of force, this is at the point of A. So at the point of A means if you are applying a force here, so if you are applying force here, so this is the point for here, so this is completely 2 meter. Okay, don't get confusion here. So after multiplying you will get the answer 4 Newton meter. We'll go to the next question now. Fourth one. The diagram in the figure shows two forces F1 equals to 5 Newton and F2 equals to 3 Newton acting at a points A and B respectively of a rod pivoted at a point O such that O equals to 2 meter and OB is equals to 4 meter. Okay, it's very easy. Here is the one rod and is the given point A and B. And at the point A, that is here the force is 5 Newton. At the point of B, the force is 3 Newton, and this is acting in the direction of anti-clockwise and this is acting in the direction of clockwise. And here for the A, the distance is 2 meter and the OB distance, that is 4 meter. It means for the anti-clockwise, the force is 5 Newton into 2 meter while doing the calculation. For the clockwise direction, 3 Newton into 4 meter. Okay, now, so what and all we have to calculate here? The moment of force F1 about O. First we have to find out this moment of force. Next the moment of force of F2. After that this. Next the total moment of two forces about O. So in the next what we have to do? That will be your anti-clockwise plus clockwise. So you will get the total moment of the two forces about O. That is only okay. We'll see. Now F1 equals to 5 Newton, F2 equals to 3 Newton, OA distance is 2 meter, OB distance is 4 meter. That is a given everything. Now next, apply the formula and substitute the values and you will get the answers. For the first F1, that is at point A, you will get the 10 Newton meter, that is anti-clockwise, and the B point you will get the 10 Newton meter, that is a clockwise. Now the third question was what? That is total moment of two forces about O. So that time we have to add the both clockwise and anti-clockwise values. So after adding 10 Newton meter, this is for the anti-clockwise, plus minus 12. As you know that the minus is the for clockwise, minus sign is for the clockwise. Okay. So minus 12 Newton. After doing, you will get the answer 2 Newton meter, but here it is not required to show the minus sign, and since it is a clockwise motion. Question number 5. Two forces, each of magnitude 10 Newton, act vertically upwards and downwards respectively at the two ends A and B of a uniform rod of a length 4 meter which is pivoted at its midpoint O as shown in the figure. Determine the magnitude of the resultant moment of the force about the pivot O. So first we will study here this diagram. Here the rod length is 4 meter. First of all, this rod length is 4 meter and here this side is A point, this side is B. Okay, so what say at the vertically, okay, at the point of A, 10 Newton, the force is applying in the direction of vertically upward, and at the point of B, which is applying in the force is applying in the downward direction respectively at the two ends A and B. Okay, now as you know the length of this rod is 4 meter and what its midpoint is O. So it means this side is 2 meter, this side is 2 meter, and for OB it a 2 meter distance. Okay, determine the magnitude of the resultant moment of force about the pivot O. Now given, okay, what and all they have given? For A, point A 10 Newton, for point B 10 Newton. As you know that for OA distance is 2 meter, OB distance is 2 meter. Okay. Now formula, as you know the formula, force into distance. First you do for the point A, this is for the point A and this is for the point B. Okay, and after substituting all the values you will get here minus 20 Newton meter, here minus 20 Newton meter. So after again substitute the values in the, we have to find out the total moment. That time we have to add these both moments. So here we will get 40 Newton meter, that is the clockwise direction. Why? Because now look at the picture also, see. it creates a clockwise direction, and so totally this is a clockwise direction. So the which rotates in the clockwise motion. Now question number 6. The figure shows two forces each of magnitude 10 Newton acting at point A and B at a separation of 50 centimeter in opposite direction. Okay. Calculate the resultant moment of the two forces. Remember here two forces about the point A, that is first, second one B, and the O situated exactly at the middle of the two forces. Okay, so first of all, now see here for point A 10 Newton is a force applying, and the point of B the force is 10 Newton, and the separation between these two both force, that is if the O is situated at the middle, that is a 50 centimeter. First you need to convert this 50 centimeter to meter, that you will get 0.5 meter. So at the force A point, that is 10 Newton, at the force at a point B, that is a 10 Newton. Next, and here now listen carefully. If the force is applying directly on this point A, that time the net force will become 0, and this force B will be, there will be distance, that is 0.5 meter. Okay, for example, if you are applying force on the hinges of the door will, it will not get open or it will not get closed. Why? Because there will be no movement. Why? Because if you are applying force directly on the hinges, means that the pivoted point for the door, the net force will be 0, because there will be no any distance. So similarly like this here. Now substitute the values. So this is the moment of force for the point A, the first question, it is there no, this one, point A. Okay, so here is the, substitute the values in the point A. As you know that the point A you will get 0, so I have not written here like this plus and 0, I written directly F into D. So here we'll get 10 Newton meter, that is a clockwise, and the second moment of force, that is at the point of B. Again, when the force is directly applying at the point of B, the point B will become a 0, and only we have to consider the force from the A, that is 10 Newton into distance is 0.5 meter. So after multiplication we will get 5 Newton meter, and this is the clockwise movement. The third question is, third question, O situated exactly at the middle of the two forces. Now this time about the point O, moment of force about point O, that is either force, that is 10 Newton, and both side is 10 Newton, and the couple arm, the difference, that is the distance, no, here it is, this is 0.5 meter, this is a 0.5 meter, that is the distance here taken, that is a 5 Newton meter, and this is also clockwise. Okay, we'll go to the next question. A steering wheel of a diameter 0.5 meter is rotated anti-clockwise by applying two forces each of magnitude 6 Newton. Draw a diagram to show that application of forces and calculate the moment of forces. So here the diagram is already draw. Okay, let me explain what they have said. A steering wheel, obviously it will be in the round shape. A steering wheel of a diameter, and the diameter is 0.5, diameter is 0.5, is rotated in anti-clockwise. Anti-clockwise means it will be rotating in this direction, so you can apply force in any direction. Okay, like this, and the magnitude and the force is 6 Newton. I think it's clear to you all. Force is a 6 Newton. Force is 6 Newton. Okay, applying two forces. Again here is the two forces shown here, two forces which is applying 6 Newton forces. Show the application of forces and the calculate the moment of force. Okay, you got here the figure now. So after this, apply the formula. Force into distance, force is either force 6 Newton, and couple arm is, that is 0.5 meter. You will get the 3.0 Newton meter. This is the anti-clockwise. Okay, now 8th question. Okay, A uniform meter rule is pivoted at its midpoint. A weight of 50 gravitational force is suspended at one end of it. Where should a weight of 100 gravitational force be suspended to keep the rule horizontal? Okay. A uniform meter rule is pivoted at its midpoint. First of all, a uniform meter rule means this is a 100 centimeter ruler. It will be 100 centimeter ruler. Uniform meter rule means it will be 100 centimeter ruler. Is pivoted at its midpoint. Pivoted at its midpoint. Midpoint means here it comes 50 centimeter. Okay. Now, and what they have said, a weight of 50 gravitational force is suspended at one end of it. Where should be, okay, so I just, here is a point A and here is a point B. So what I did here, 50 gravitational force of the 50 gram of the weight I suspended the point of A. Okay, now after suspending, what is the next question they are asking? Where should a weight of 100 gravitational force be suspended to keep the ruler horizontal? So, okay, so we need to find here one more weight it is there, that is 100 gram. So I don't know where is, on which point I should place this 100 gram weight. So this ruler, it should become a uniform. Okay. First we will learn the calculation according to the principle of moment. Before that, okay, before that, this is the anti-clockwise, this is the clockwise. As we learn in the state of the principle of moment, what it says, sum of the anti-clockwise is equals to sum of the clockwise. Okay, so here start doing the calculation. 50 gf into the distance is 50 centimeters. See, the complete ruler is 100 centimeter. At the point up to point O, it will be 50 centimeter. Do the multiplication in between 50 gf into 50 centimeter and here 100, and the at which point I should place this 100 gram, that I don't know. For that I given the name, that is X. Okay, now do the calculation. After calculation and all, you will get the 25 centimeter. This 100 gf, it comes down. Okay, cancel the 0 0 0 every here. So you just, what remains here, 5 5 5 5 5 is a 25 centimeter. So at the point of 25 centimeter, if you placed 100 gram, so the ruler, it will become a uniform. Okay, see, one more thing. In a rotational motion, we have learned that is, if the distance is maximum, there will be more rotation. So in this of ruler, as the distance get increased, as the distance is maximum, it requires, there will be lesser weight, and if the distance is smaller, there will be weight will be more. Okay, to adjust the rule. It's not like that if I'm getting here 100, that I cannot place at 100 centimeter. Again it will start to tilt in the direction of clockwise direction. Okay, so if it is a weight is more, means the it takes the distance less compared to the another weight if it is lesser than that. Okay, remember this. Next question. Okay, ninth one. A uniform meter rule, again, uniform meter means it comes 100 centimeter only. Remember, a uniform meter rule balance horizontally on a knife edge placed at the 58 centimeter mark when a weight of 20 gram force is suspended from one end. In this, what and all we have to do, draw a diagram of the arrangement and what is the weight of the rule. Okay, what is the weight of the rule actually here? Okay, here is a 100 centimeter ruler, but Actually 50 centimeter is the midpoint, but this ruler is balanced at 58 centimeter mark, and the one weight of 20 gf is suspended from one end. Obviously it will be suspended at 100 centimeter. Why? Because up to 50 centimeter this side the mass is more. So to balance this ruler, we have to keep this 20 gram at the 100 centimeter only. If it is this instead of 58 centimeter, if it's somewhere lesser than 4 lesser than 50 and all, that time we have to place this 50 gram force at the time of this side, that I can say A. Okay, I think you understand, you all. Now I think it's clear to you all about the diagram. Next, according to the principle of moment, again formula, you know that what I did. According to the principle of moment, sum of the anti-clockwise and sum of the clockwise moment. Now here W, this side weight we don't know, that only we need to calculate the weight of the scale. For that 58 is the here the on the edges place, here it is 58 centimeter, and up to 50 centimeter is a midpoint, that is 58 minus 50, we will get here 80 centimeter. That much length of the weight only we have to find out. And this side here it is up from here to here, that the distance is 100 centimeter and minus 58 centimeter, then only we will get the exact this distance, that is 20 gf into, we will get here 42 centimeter. I'm really sorry, my student, she has written very badly here. At the end of the classes she will write like this only. So substitute the values. This 8 centimeter comes down here, cancel the centimeter, and multiply in between 20 into 42, you'll get 840 divided by 8. 8 ones are 800 and 5 is 840. So your force is, it's not a force actually, it's a weight. So weight is 105 gf. So it means this side weight is 105. So this side is 105 gravitational force is there. So then only this ruler it is balancing. Okay, I think it's clear to you all. So I'm going to finish the video now here. So remaining the problems we will discuss in the next video. Thank you.